So let's study what is resolution of a force. We have taken a right angle triangle with this angle as 90 degree and this angle is theta. So in this right angle triangle, let's say the hypotenuse is r. So we have the opposite side and the adjacent side. Now from my trigonometric ratios, I know sine theta is equal to opposite upon hypotenuse. So can I say my opposite side therefore will be hypotenuse into sine theta. So hypotenuse is r. So I'll get my opposite side is equal to r sine theta. Similarly, I have my cos theta is equal to adjacent upon hypotenuse. So my adjacent is equal to hypotenuse into cos theta. Hypotenuse being r, I get that is equal to r cos theta. So I can write my adjacent side is equal to r cos theta. So if I have any line like this, if this angle is theta, which it makes with this, if I drop a perpendicular, if this is r, the opposite side is r sine theta and this adjacent side is r cos theta. Suppose we have the x-axis and y-axis oriented likewise. If my angle is say theta, which it makes with the positive x-axis in the anti-clockwise direction. So positive x-axis. So this is my positive x-axis. I measure it in the anti-clockwise sense. In the anti-clockwise sense from this base. Yeah. So this is my angle, which this vector, let it be f. So if I drop a perpendicular, I will get this value as f, we just studied, it is f sine theta, which is equal to this value. So this is the projection of the vector f on the y-axis, that is f sine theta, and the projection on the x-axis is f cos theta. That is how you resolve a vector. You consider the angle theta which it makes with the positive x-axis. So if we have the vector is oriented, say it is in the second quadrant, it's pointed. So this is my theta. So this would be my projection on the x-axis. So this would be my f cos theta. Please note, f cos theta is pointed to the along the negative x-axis. So theta being greater than 90 but less than 180. In the second quadrant, cos theta is negative. So I'll get my projection is along the negative x-axis. So my f cos theta is also negative. My projection of the y-axis is going to be f sine theta. So second quadrant theta, sine theta is positive. So is my f sine theta. If I try my unit vector notation, in my unit vector notation I have unit vector is a vector of unit magnitude. So I call this as I cap and this is j cap along the y-axis. So I can write f cos theta in this direction I can write it as a magnitude of F cos theta times the direction, which gives me a complete vector, F cos theta I cap. Similarly, my F bar sin theta, it's oriented along the y-axis. I can write it as the magnitude of F sin theta, and the direction I will get it from j cap. From triangle law, I can write let me extend this further. I can even call it as Fx, which is my x component of the force, and this is Fy bar. So I can write my F bar is equal to Fx bar plus Fy bar. This is from triangle law. I can also write it as F bar is equal to Fx is my F cos theta I cap plus F sin theta j cap. So this is how I resolve the forces.